Greetings, fellow mathematicians. Welcome to a little corner of the internet called Marshable Math. Today's lesson is going to be on polynomial long division. So get some paper and a pencil and maybe a calculator handy. Remember that it's your job to control the time, so please feel free to press pause, rewind, maybe even fast forward. It's up to you. Now, if you're like most math students, when I said long division, your eyeballs rolled back up into your head and your mind went a complete blank. And then it's even worse because I added a big word there, polynomial long division. But if you stay with me, I actually think you'll like the lesson today. It's kind of neat. Okay, so for starters, what I'd like you to do now with your piece of paper and a pencil is I'd like you to remember back to maybe 4th or 5th grade math, and I'd like you to do just a very simple long division problem. Okay, I want you to do 3,045 divided by 12. So go ahead and press pause on the video. Take a piece of paper, take your pencil. Let's see if you can still do that. No, seriously, like, you need to do it. You'll be kind of lost today in the lesson if you don't do that. It's important for you to give it a shot. Go on, I know you can do it. Done yet? Okay. You may be thinking, gee, why did you write it out in words? Well, I'm making you translate it into numbers. Okay. So 3,045 divided by 12, probably on your paper, looks something like this. 3,045, how many hundreds? No hundreds, right? Divided by 12, that should be the starting part. Notice if I don't have any hundreds, I have to put a 0 there as a placeholder because the number system that we use is positional. Okay? We have the ones placed, the tens placed, the hundreds, and the thousands. I don't have any hundreds, so I have to use a 0 there to hold the place. If I just wrote 3, 4, 5, it would have meant a different number. Okay? So now remember the division algorithm. All right, so the question is going to be, what do I multiply 12 by to get close to 30 without going over? Let's see here, 12 and 24 and 36, so 2, right? And where do I put the 2? Does it go above the 3? If you remember right, position's important. I've got to put the 2 above the 0 here because that's the last number that we're considering in the problem so far. Now I take 2 times 12 and I multiply. I get 24. I do what? Subtract. Oh, let's see here. Take 4 from 0. Can't do that. Got to regroup. Borrow perhaps. That becomes 6. Arrow down here. That becomes 4. How many times does 12 go into 64 without going over? 12 times 5 is 60, right? So that would be 5. 5 times 12, 60. Do the subtraction. I get 4. Bring down the 5. What do I multiply 12 by to get as close as I can to 45 without going over? 12 times 4 is 48. That's too much. 12 times 3? 3. 3 times 12. 36, and I get off the screen there, I get 9. I could put a decimal here and keep going, but let's talk about remainders. Let me just leave that as a remainder 9. Now let me talk to you about some of these vocab terms here, all right? So what we've got is we've got dividend. That's the thing that is being divided. You might call it the dividee, right? So the dividend here is 3,045. The divisor is the thing that's doing the division. That's 12. The quotient is, of course, the answer to the division problem, and we've got remainder of 9. All right, so what does that mean? That means that 3,045 divided by 12 is equal to 253. Remainder 9. How do I write that? Can I do this? Can I say plus 9 over 12, right? Okay. But what if I multiply both sides of this equation by 12? Do I not get that 3,045 is actually equal to 12 times 253 plus 9? You see that? This is actually very important. The dividend is equal to the divisor times the quotient plus the remainder. Now maybe you don't feel that quite so well as you might if I use smaller numbers. Let me use smaller numbers. Let's do, I don't know, 26 divided by 4. Okay? How many times does 4 go into 26 without going over? That'd be 6. So 6 times 4 is 24. And then we got a 2, it's the remainder 2. Can't I say then that 26 is equal to 4 times 6 plus 2. Okay? Yeah, good. All right. So, you know, you can still do long division. I knew you had it in you. What does it have to do with polynomial long division? It's the same thing, kind of. Okay. Remember I said we had our place value system. Here was base 10, right? This is ones, tens, hundreds, thousands, and so forth. And maybe if you're like me, your teacher in maybe 4th or 5th grade got on you for like, you know, drifting and not using the lines on the paper. Maybe you even had to like do your long division with like on graph paper to keep the columns lined up. Well, that was good. That's important, right? So let's see here. I've got the ones column, and I've got the tens column, and I've got the hundreds column, and this is the thousands. Let me put labels to this now. This is the ones column, and since we use a base 10 system, how many tens is this? None. Now, the tens column, how many tens is that? 1. Hundreds column, how many tens is that? Oh, it's 10 squared, right? Isn't 10 squared 100? Thousands column? Oh my goodness, 10 cubed, right? Can you do it with exponents? No, you could. Now, polynomial long division says, hey, let's do division when we don't know what the base is. You say, what? What are you talking about, Willis? I mean, what are you talking about, Mr. Marsh? Well, okay, so I don't know what the base is. I'm going to give you a problem, and I'm not going to tell you what the base is, but I want you to do the division. Okay, let's sort this out. If I don't know what the base is, let me replace it with something just to hold the place. And of course, in algebra, we use variables, right? And so what variable do we use usually to represent the numbers that we don't know? Well, that would be x. So let me come through here and say, oh, 10. Well, I'm going to replace that now with an I don't know. And I'm going to replace this 10 with an I don't know. And replace that one with an I don't know, and that one with an I don't know. Starting to look like a polynomial? Okay. And notice this one was, oh, 3 thousands and no hundreds and 4 tens and 5 ones. Let me convert this now into a polynomial. What if these were the number of I don't knows that I've got? It might look like this. Let's see here. 3 I don't know cubes plus, I don't have any of the I don't know squares, plus what, 4 I don't knows plus 5 with none of the I don't knows. And I'm going to divide that now by 1 10 and 2 ones. Doesn't that come over to 1 I don't knows and then 2 with no I don't knows? Are you following this at all, right? This is the tens, this is the no tens, but we don't know now, so we're calling it the x's. It's the x to the firsts. There's your polynomial long division problem. Oh boy, we're going to do it the same way we did this one. Now remember, you didn't have a 0 there, you didn't have 100 in the listing here, so you had to put a 0 there as a placeholder. You have to do the same thing with this one. We have to write it in standard form, right? And so now we're going to say, all right, let me write it in standard form. I'm going to write 3x cubed plus no x squareds plus 4x's plus 5. And remember, this is the x to the 0 column, sorry. This is x to the first column here. This is x squareds here, and this is going to be the x cubes column there. And I'm going to do my division now. Divided by x plus 2. Okay. Now what? It's actually a little easier because all I'm going to do is look at the first elements right here and right there. Okay? This question said, how many times does 12 go into 30 without going over? This question says, what do I multiply x by to get 3x cubed? Would that not be 2x squared, right? But where do we write it? Well, where do we write the 2 here? Didn't we write it above the place value here that we were the one considering? Yeah. Well, okay, where's the squared place value? It's here. So if I'm going to say x times 3x squared, it has to be in that column right there, right above the proper place value. 3x squared, okay? That's what I multiply x by to get 3x cubed. Now, once you've got this far, you do the same thing here. 2 times the 12, subtract. 3x squared times now this binomial, whatever's here, your whole divisor, 3x squared times x. Oh, 3x cubed. 3x squared times positive 2. What's that? Plus 6x squared? Okay. Now, subtract. Yeah. But you've got a group here. You're subtracting the group. How do you do that? My simple way of thinking about it is you just change the sign and add, right? You add the negative, which is oftentimes confusing to me, but in this case it actually works, okay? So change that to a minus, change that to a minus, add your columns. 3x cubed minus 3x cubed. You should always get 0 right there, right? Put a smiley face if you want to. Makes you happy. You know you're doing it right. Combine this column, 0x squared minus 6x squared. Oh, that's minus 6x squared. And I'm going to go ahead and bring on down the other pieces here. They get lonely. Plus 4x plus 5. Okay, same process. What do I multiply x by to get negative 6x squared? Well, let's see here. Negative 6x. Where do I write it? In the x column. Negative 6x. Now, multiply again. This term times all of these terms, negative 6x times x, negative 6x squared. Negative 6x plus 2, negative 12x. Okay? Subtract the group means change the sign and add, so plus plus. Hey, happy day. And that's what, 16x, and then bring down Mr. 5 here. What do I multiply x by to get 16x? Well, that's positive 16. Okay, 16 times x minus 16x. 16 times 2 would be positive 32. Change the sign and add. So that's, again, joyful. And what's that? Same sign, no different signs. Subtract the numbers. 32 minus 5. What's that? Negative 27? Okay, and I'm kind of done, so this is now remainder 27. Okay, follow? This is your dividend, this is your divisor, that's your quotient. But it means the same thing that it meant over here. Remember, we can write the problem as a dividend is equal to the divisor times the quotient plus the remainder. That means this right here, make myself a little room. That means the dividend, 3x cubed, I'll skip the 0, plus 4x plus 5 is equal to x plus 2 times the quotient, I'm running out of space, 3x squared minus 6x plus 16, and then it's, it's minus 27. I double dog dare you to multiply this out. I'll bet you get that guy right there. All right, ready to try one on your own? Wow, man, that's a lot of x's, right? What does an x mean? I don't know, right? We just use it to represent something that we don't know quite yet. So, man, I wish there was a way we could do this without all the x's around. That's just cluttersome. That's a tie-in for another lesson. But look at this. I got an x over here, and an x over here, and here's an x, and there's an x, and everywhere I've got an x. So old MacDonald asks, what's x? And gee, I just don't know. You didn't see that coming, did you? All right, so let me give you a problem now to try. With your paper and pencil, I'll leave this one up if you want to maybe go back through and follow the steps. Let's try this one. Let's try 6x cubed minus 19x squared plus 16x minus 4, and let's do divided by x minus 2. So set it up right. See if you can do this now. Okay? Go ahead and press pause on the video. I'll check back with you in just a minute. Okay, ready? Let's set it up. First question, is it in standard form? That means counting down by exponents, right? Cubed, squared, first, none. Okay, so it's in standard form. Do I have any missing place values? Well, no, 3, 2, 1, 0. Got them all. All right, so I need to set it up. 6x cubed minus 19x squared plus 16x minus 4 divided now by x minus 2. Give myself a little break here. Okay, let's run through the process. What do I multiply x by to get 6x cubed? Well, the number here is 1, so that would be a 6x squared. Let's write it in the column. 6x squared. Now, multiply through. 6x squared times x, 6x cubed, which they should be the same thing, right? Okay, 6x squared minus 2, that would be minus 12x squared. All right, change the sign and add. I'm happy, how about you? And that's going to be minus 7x squared. Bring down the rest of the gang, plus 16x minus 4. Okay, now what do I multiply x by to get negative 7x squared? Well, okay, negative 7x. So minus 7x. Multiply this term by all of those terms. Negative 7x, negative 7x. Ooh, squared. Yeah, because it's got to match, right? So then negative 7x times negative 2, that's a positive 14x. Change the sign and add. What a great day today is. What, 2x? And then minus 4. Okay, now what do I multiply x by to get 2x? Well, that would be a positive 2. Okay, positive 2 times x, positive 2x. Positive 2 times negative 2 is negative 4. And did you see where this is going? All right, did you get this too? What have you got for your remainder? A 0. What does that mean? Well, it means that x minus 2 is actually a factor of the original polynomial here. Well, that means I can write 6x cubed minus 19x squared plus 16x minus 4 is the same thing as the divisor x minus 2 times 6x squared minus 7x plus 2 with no remainder. I've just factored it. Oh my goodness. Well, you see, all that time you spent in 4th and 5th grade math doing the long division is actually paying off. Okay? I hope you haven't forgotten those skills yet. Too oftentimes people are, they're too dependent upon their calculator to do their mathematical thinking for them. But not you guys. Okay? Now I got a question here. What was the whole point of doing this? Well, we're finding the relationship between things and we don't even know what the base is. What branch of math is it that actually looks at the relationship between the values as opposed to just the values themselves? Okay? You know? It's music. Say, well, what are you talking about, Mr. Marsh? Music? Yeah, music as defined by Nicomachus, remember? Relative quantity. Arithmetic is absolute quantity. Quantity just by itself, the properties of numbers themselves, absolutely. But music is, what are the properties of numbers in relationship to other numbers, right? And if you think about that, yeah, that's kind of music. Although we think of music today as just like sound and the relationship between sounds, which are numerical, okay? But no, this is kind of in the classical sense, it's music. It's the relationship there. In fact, you might even say harmony is what is the good relationship? What's the proper relationship among things? There's two other mathematical studies that were part of the Southern liberal arts. Do you know what they are? I hope so. If not, you should go look them up. Okay? Well, I hope you've had an enjoyable time. Believe it or not, long division can be fun, even if it is polynomial long division. I hope you have a great day.